Welcome to qnawire.
So we can use the solution from problem 10.86, and from there we know that conservation of angular momentum shows that r1 v1 is equal to r2 v2, and using that relation in part A, we see that tension is equal to m v1 squared r1 squared by r cubed. In part B, we need to find out the work done from this following integration. So this is t vector dot dr vector. So since we know that tension vector t vector and dr vector are always antiparallel, so the dot product of them will give us a negative sign, and then this becomes a scalar. So if we substitute this value over here, we see that it's negative r1 r2 t dr. Now what we can do here is we can get rid of this negative sign, and if we do so, our limits will switch. So r1 will become r2 and r2 will become r1. So this is going to be r2 and this will be r1. Now we can use the expression of tension and plug it here, and if we do so, we see that this is r2 r1, then we have m v1 squared r1 squared by r cube dr. So let's write down that equation one more time. We have m v1 squared r1 squared integration of r2 r1 dr r cubed, and that gives us m v1 squared by 2 r1 squared 1 over r2 squared minus 1 over r1 squared, where we use this following relation. So if we do the integration of dx over x cubed, we can write that as x to the power minus 3 dx, which gives us x to the power minus 3 plus 1 divided by minus 3 plus 1, which is 1 over 2 x squared, and there's a negative sign. And since there's a negative sign, that's been taken care of in the limits, and that's why we have r2 in front of r1 and there's a negative sign in front of r1. So yeah, so we can use this relation and then take the limits as r2 to r1 and then solve for this. Right. Now in part C, we can see that v2 is equal to v1 times r1 by r2, and the change in kinetic energy will be delta k, which is equal to half of m v2 squared minus v1 squared, and from there delta k becomes m v1 squared by 2, and we have r1 minus r2 squared minus 1, which is exactly equal to the work found in part B. So that means this is equal to answer in part B. Thank you.